All right, so we are now recording. This is a demo of Crossplane for Working Group K8s-infra and friends. And so we're going to be showing a potential path forward for using Crossplane to manage some of the infrastructure that's currently managed via Terraform and Bash scripts and some other methods right now for some of the test infrastructure for Kubernetes. And this is under the Kubernetes Code of Conduct, which can boil down to be excellent to each other. So please make sure to adhere to that. As I mentioned before we started the recording, we'll also make this available on YouTube. So if you miss anything, you can always follow up with that. And you can also share it with anyone else who's interested. But this morning at the regularly scheduled K8s-infra meeting, I gave just a very quick overview of what it could look like to use Crossplane to manage some of our infrastructure. So today I'm going to focus on a few different things. Number one, giving a little bit of background on Crossplane. I don't think we need to spend too much time on that because as folks who are familiar with Kubernetes, it'll probably be fairly intuitive. And then we're also going to be doing a demo of actually using it in action so folks can get a feel of what the architecture might look like. And then we can just do a little bit of Q&A and brainstorming. Definitely feel free to put anything in the chat while I'm talking, or you can speak up and interrupt me as well. I'm totally fine with that. But I'll definitely stop periodically as well to check if folks have questions. All right. So as I mentioned, I do have a short little presentation here that I'll probably speed through pretty quickly. Like I said, this is kind of focused on folks who are less familiar with Kubernetes. So not going to spend way too much time on it. All right. So basically, Kubernetes is or Crossplane is trying to take the approach of managing all of your infrastructure via Kubernetes. As we've experienced, right, with Working Group K8s-infra, there's issues with having to run things from your local machine, like execute Terraform scripts or run Bash scripts to be able to provision or verify infrastructure. So we'd like to take the same approach of a reconciliation loop in driving a spec towards a status or driving status toward a spec, excuse me, with our infrastructure as well, and also be able to make use of the Kubernetes API to do that. This is kind of a look at how modern application teams can utilize Crossplane. A little less focused on that here, as we don't have a traditional org here. However, with Kubernetes, I think it's really important that the infrastructure that we manage, we also enable other people to spin up similar configurations, as well as add and edit as needed, via our typical PR workflow. So Crossplane aims to, enable those types of things by being able to define your own abstractions, as well as enforcing security and policy and kind of just exposing the knobs to folks that you want them to be able to turn. So this is taking a little bit of a look at what it could look like to have a lot of different infrastructure from different providers managed by Crossplane. Today, I'm primarily going to focus on GCP since that's what we use right now. However, I know this morning and in other conversations, there's been talk about wanting to utilize other cloud providers or being able to spin up the same infrastructure on, AWS and Azure, et cetera, as well as potentially allowing folks to run this kind of infrastructure locally and do conformance testing and that sort of thing. So Crossplane is definitely cloud agnostic in that you can write a provider for essentially any API. And we'll get into exactly how providers fit into the Crossplane picture in a little bit. But essentially, they are sort of opinionated Kubernetes operators that focus on a particular API. So once again, this is focusing on platform teams a little bit, but essentially it boils down to wanting to be able to enable folks to be able to provision their own infrastructure, so self-service infrastructure, as we like to call it, as well as give the proper tools to the infrastructure team, which in this case would be maintainers of some of the K8s.io infrastructure to configure everything they need to and decide what knobs people can turn. All right, I'm going to skip through this a little bit. So This is kind of the picture that we typically show folks when they are looking at how they're going to use Crossplane. So what we'd see in our platform API, if we take the current structure that we have for the working group K8s-infra infrastructure that's managed, our platform API would essentially probably be the Git repo, and we would have some sort of CI/CD pipeline that watch changes to that Git repo. So right now we frequently commit changes to Terraform or Bash, and then have Aaron or someone run those scripts locally to provision that infrastructure, to verify that some infrastructure is in the correct state. And that's obviously not a great practice that we'd like to move away from. So you can imagine in this case that the platform API that we want to expose would be a Git repository, at least for now. And then Crossplane would be running in a Kubernetes cluster alongside, whatever CI/CD pipeline we had set up to actually create objects in that cluster, and it would expose all of the different infrastructure APIs as CRDs in that cluster that could then be created and managed and evaluated for their health and that sort of thing. You can expand any aspect of Crossplane, like I said, by writing a provider, which will basically just bring along all the different API types for a given cloud. Like I said, don't need to spend a lot of time on how the Kubernetes model works, right? A lot of folks are already familiar with this model and the benefits of using Kubernetes objects and the Kubernetes reconciliation pattern to manage infrastructure. But obviously, when you have things represented as Kubernetes object, you can make use of things like, the authorization model, RBAC, all that sort of thing is kind of just out of the box when you're using this API control plane. The XRM model is something I want to point out. That's kind of Crossplane's opinionated model about what a CRD should look like that represents infrastructure. You'll probably hear me reference managed resources throughout this presentation. Managed resources are what we call the granular cloud APIs that we represent as objects. So if you go and look at the GCP API or the AWS API, they're going to have different objects essentially that you can perform CRUD operations on. So an example of that would be a GKE cluster, a node pool, an IAM group, et cetera, similar to what kind of resources that Terraform would expose. And so those are the managed resources, which typically fall into our XRM category, and they expose common status and fields that allow you to specify what credentials are used to provision them, as well as evaluate their health by looking at their status and synced conditions, which we'll see a little bit later on. All right. So once again, this is just talking about key use cases. We're pretty aware of the use case that we're looking for here today, but there are some other ones that we could grow into that are enabled by using Crossplane. But essentially, we want to be able to manage our infrastructure through Kubernetes. And that's the main thing we're going to focus in on today. And I'm going to talk a little bit as well about distribution of that configuration, because as I said, sort of towards the beginning, I think that's an important part that we currently don't have a great story for. Okay, so composition is kind of the next level that takes Crossplane from just like an infrastructure as code tool plugged into Kubernetes to what we like to call a platform definition tool. So we bring all these different providers that expose managed resources. So here you'll see some of them down at the bottom, such as an RDS instance or an Azure MySQL instance, subnet groups, networks, etc. Those are all brought by providers and are reconciled by controllers that are part of the providers. And you'll see they have names like provider AWS and provider Azure. Then, as an infrastructure team or an infrastructure admin, you're able to define abstractions on top of those that can be satisfied by what we call compositions. So, in this case, you could have a composition, for instance, that was called a composite MySQL instance, and that could be backed by different services from different cloud providers. Or even different services on the same cloud provider or different sizes of services on the same cloud provider. Essentially what this composition or this XRD, which is the abstract type, does is it allows you to produce two variations as CRDs. So if you create a composite MySQL instance, you'd actually end up with a composite MySQL instance cluster scoped resource, and a MySQL instance namespace scoped resource. The reason why we have that model, which I'll once again get into more in a little bit, is because folks have different multi-tenancy situations where they'd like to expose some resources at the namespace scope, potentially for application development teams, or at the cluster scope, potentially for infrastructure teams. So in a little bit, we're going to look at an example where we have a network XRD and a cluster XRD. The network XRD we only expose at the cluster scope, because that's typically something that's set up by network admins. A good example of this could also be something like a GCP project. That's typically not something that you'd have someone spinning up themselves, right? That would be something that would be defined by an infrastructure team, and then consumed by an application team. Um, a cluster, on the other hand, may be something that an application team spins up themselves, or maybe it's something more granular than that. But something that they may want to self-service infrastructure on. And then I talked a little bit earlier about the distribution story. So we have all of these different providers, and then configurations are the packages that we use to take those abstractions and make them easily distributable. Um, the way we pass around all of these different configurations and make it easily reproducible, so basically able to install a platform into a Kubernetes cluster and get those same abstractions across a number of clusters, is we have basically opinionated OCI images that you can push to Docker Hub or GCR or whatever registry you prefer. And that makes it really easy for you to replicate this kind of interface in different clusters. So from a Kubernetes perspective, we might have, a prow cluster abstraction that we may want to make easily available for folks. Someone could go and, get a Kubernetes cluster, whether it's on their local machine or on GKE or wherever, and go and install the k8s-infra package. And it would install not only the necessary providers, so maybe like GCP and AWS, for instance. It would also bring along those abstractions and give them a CRD that was a prow cluster where they could just create that directly, and get the appropriate configuration for that. So this is once again just kind of a little bit more of a depiction of that separation of concern. And this is getting into the demo area. So I want to go ahead and hop into that portion of the presentation. Before we do that, though, I want to see if anyone has any questions kind of right off the bat. All right. Well, we will go ahead and continue on. And like I said, that was kind of a lot of information, but I think actually having concrete examples is going to make this a bit more consumable. All right, so I'm going to hop over to the documentation for Crossplane here. And this is not super important except for to show you kind of what the process is for setting this up, because it will give you more of a look into, what the actual architecture of the infrastructure would look like behind the scenes. So Crossplane as a Kubernetes add-on is something that you can install into any cluster. So typically you go with the self-hosted Crossplane here, and you just install it via Helm chart. Core Crossplane actually doesn't bring any of these cloud provider managed resources. What it brings is the packaging system and the composition system. So after you install Crossplane, you actually have to go about installing configurations or providers into your cluster via Crossplane. And what Crossplane does is it makes sure that the appropriate CRDs come in. It makes sure to start up the appropriate controllers and watch them. And it also makes sure you don't have two controllers, conflicting, trying to reconcile the same thing. So, for instance, if you tried to install provider GCP and then you tried to install, some other sort of GCP thing, that was going to try and reconcile the same objects that provider GCP was reconciling, it would say, this is going to happen. Are you sure you'd like to? So I've actually gone ahead and spun up a GKE cluster, and have it going here and have installed Crossplane. So if we go and look in the Crossplane system namespace, we'll see that we have Crossplane and the Crossplane RBAC manager, which I can provide a little more detail on in the future if you'd like, as well as some other pods here running. And I'll explain in just a moment what those other pods bring. But before we do that, I want to talk about the different CRDs that just installing Crossplane brings. So we'll do kget CRDs, grep crossplane.io. And this is probably going to show us a lot of CRDs because we have those other providers installed. But if we didn't and we went up a little further, we would have things like provider resources. Let's see if I can find a good example here. We should have compositions. Let's see. So the composition type is going to be, I'll pull it up here as an example. The composition type is the type that we basically create to specify a group of resources that can satisfy an abstraction. So here's an example of the composition, which is in the API extensions crossplane group. And you'll see here that we are saying that a Postgres abstract instance can be satisfied by an RDS instance on AWS. It can also be satisfied by a Cloud SQL instance on GCP. And you'll also see this mapping of these from field path and to field path with some light templating on top of that, that basically takes this XRD or composite resource definition, as we call it, and takes the schema and maps that to the underlying resources, which means you're picking a schema that is appropriate for the different concrete implementations and passing those along. So for instance, here for the Postgres instance type, we're defining a storage GB field, which is just the storage of the database, which is kind of a generic parameter that would be applicable to all Postgres instances. And then in our compositions here, for RDS, we're passing that field along to the allocated storage field. And these map to the AWS API directly. And then in GCP, for instance, we're passing that along to the data disk size GB. So this is kind of a simple example of what an abstraction could look like. What I have currently present in the cluster here is a bit more complex of an example. So this is actually from this platform ref wg-k8s repo, which is essentially giving you an abstraction across Kubernetes clusters and exposes it in two primary abstractions, one being a cluster and one being a network. So we'll once again see something that looks very similar to the documentation I was just showing for a network. You can ignore these annotations for this time being. This is for some UI that we'll get into in a little bit. But you'll see we have a pretty simple network schema here that just has something like an ID and a cluster ref in it. And on GCP, that's going to map to a network and a subnetwork. And then on AWS, that's going to map to a VPC, internet gateway, subnet, or multiple subnets, a route table, a security group. Essentially, it takes more resources on AWS to get a similar type of setup. And that's kind of the powerful thing about having the abstraction, right? Is you can choose your cloud provider, and the details about what you want are kind of hidden from the end user. So that's definitely a benefit of that. And if we look in our cluster here, we should be able to see that we have a CRD that represents this composite networks type. So once again, this is not a custom resource definition. This is a composite resource definition. So we should have a namespace scoped network type and a cluster scoped composite network type. So we'll see those here. Here's our networks wg-k8s type and our composite networks cluster scoped type. And essentially what this gives us is the optionality to create things at the cluster or namespace scoped. You'll see for some of these, we don't even give the option to create them at the namespace scope. For instance, the EKS and GKE abstractions, which create things like a GKE control plane and a node pool. We're just saying, that's a infrastructure admin kind of thing. We don't want to expose that to the different users. Likewise, we also have a cluster abstraction, and I won't go too deep into this, but it once again has kind of a stripped down abstraction. You'll see we've taken general categories like small, medium, and large cluster, and on the various providers mapped those um, to a given size. So I don't remember exactly what that field was, but essentially it's specifying our node count on GKE and a different field on EKS. Another thing you'll notice here is that we have a nested definition here. So you can do, a nesting of your abstraction. So we have a GKE abstraction that maps to a GKE cluster and a node pool. And then we have an EKS abstraction that maps to, once again, as you'd expect, an EKS cluster. But I don't know if you've ever spun up EKS. It's much more involved than spinning up a GKE cluster, which is why there's a whole CLI dedicated to doing so. So there's quite a bit more resources here to get a similar type of setup. Another thing I want to point out in this specific configuration is that we also have this services directory, and this is where we can kind of get into more, I guess, advanced use cases. But this composition is using provider Helm. So we've talked about different cloud providers for managing infrastructure. Providers can represent any API. So in this case, we're using provider Helm, which represents the Helm API or the Kubernetes API essentially, that allows you to reference a Helm release and install it into a cluster. So we're actually, when we take this abstraction and putting this all together for GCP, for example, we're creating our GKE cluster abstraction and then our services abstraction, which in this case is just Prometheus. And we're referencing the cluster that we're creating. So that service is actually going to wait for the cluster to come up, and then it's going to deploy Prometheus into that cluster. You can imagine some of the tooling that we want to drop into clusters. That could be a useful thing. And the only actual object we have to create to get this whole setup here would be this cluster type, which is pretty stripped down. And you can see the only thing that's really specifying this GCP at all is saying map to the composition that has a label GCP. And you can kind of go ahead and create your own label schema that maps appropriately. So I will stop talking in just a moment, but I want to show you exactly what this looks like in the cluster. Well, actually, one more thing I'd like to show you before we do that is, as I mentioned before, this can all be packaged up into an OCI image and pushed to a registry. And you do that with this crossplane.yaml. And you can do things like declare dependencies in here. So once again, this is kind of similar to Terraform. Although we're actually installing controllers into the cluster that are going to reconcile objects. So here we're just specifying some dependencies, and this is using the Upbound registry. These are also available on Docker Hub. You could push them anywhere you like, and some restrictions on them. So to actually install all of these different providers and get them set up, I used a single command that was kube control crossplane install configuration. And I referenced the OCI image, which is actually the bundling of all of these YAML files that we were talking about. And Crossplane knows how to unpack that and install the appropriate providers. So if we look at our packages in the cluster, we're going to have things like the overall platform ref multi-k8s, which is what I installed, and then all of the different providers. And you can see that if we look at our configuration revisions, which we can talk a little bit later on if you'd like, about how you can upgrade and roll forward and roll back providers and configurations, but it's very similar to how Kubernetes works. It's inspired by that model. But you can see that it actually identified 4 dependencies which had been specified in our crossplane.yaml here. And then it found the latest version that fit these version constraints. So for instance, for provider Helm, we said v0.3.6 or greater. And the version installed here is v0.5, right? Because that's the latest version that's greater than constraint. So we get some nice features by going through Crossplane in that way. And when these providers are installed, they bring their CRDs with them. So you can see that we'll have all of our GCP types for the granular things that the GCP provider currently supports, which I'll be very transparent. Right now, we don't have full coverage for every provider. We do add them fairly quickly, and we're working with the various cloud providers for that. You can see kind of different cloud providers' involvement by looking at the supported resources. So right now, in the latest version of provider GCP, we have 20 resources. If we look over at something like provider AWS, which we've been working with them to generate the resources, we have something like 58 available. Like I said, it's not a super big burden to add additional resources, but it does take some effort. So just want to be upfront with that, right? If there are resources that we need support for, there could be some lag time in getting that implemented and then being able to use it upstream. So with all these different types available, and the AWS ones are here as well. We also have the multi-k8s types, which I believe I showed earlier, but I will display them again. And these are kind of the abstraction. Let's see. What is the actual, platform ref? Here we go. This is actually API version here. So these are the kind of abstractions that we've made available. You can, do RBAC around these different resources to control who can create what or who has access to what. But these are kind of those abstractions that we defined. And if we looked at our different compositions, we would see the things that back each of these different abstractions as well. And you can have arbitrary number of compositions that support a single abstraction. Before we got started, I went ahead and actually created some instances of these resources because it does take some time for something like a GKE cluster to spin up. So I created two different things. I created a network, which is in our multi-k8s group. So this is an abstraction that is backed by some resources, and a cluster. And the cluster actually references our network. And we can talk a little bit about how cross-resource references work in Crossplane. But if we actually get these, you can see that we have an abstract type called network GCP here. And then we also have an abstract type for cluster.yaml. And it looks like that one is still provisioning. And then using those compositions, when we created those resources, you'll see that we actually got the granular resources that I showed kind of in the slice of resources in the composition. So if we look under the hood here, we have things like a network, a subnetwork. The provider config is basically just how we supply credentials, which we can talk a little bit more about using things like workload identity for that if you'd like. And then we also have things like our GK cluster here and our node pool. And then if we look at the Helm resources that get created, because once again, that cluster type came with Prometheus, we have this Prometheus release here, which actually looks like it had trouble installing. But it's present as well in the clusters. You can see kind of how these different abstractions came about. And so looking at how this could kind of be manifested in what we currently do for infrastructure, there's obviously the resources that we currently represent with Terraform. But generally, the way this would likely look is we have a Crossplane cluster running, and then some way to create the objects, based on merges to the Git repo. Those will get created in the cluster, and then Crossplane would take care of actually provisioning those. It also keeps them healthy. So sometimes in these demos, we'll show like, going and deleting our node pool or something like that. Crossplane will recognize that, spin up another node pool with the proper configuration. So it's auto healing in that regard, which, comes with running on top of Kubernetes. And so we would likely, have setups where we'd have, this is the base one where Crossplane is installed, and this is actually the GK cluster we spun up with it, which we could run prow in, or something like that. But there is a lot of flexibility here. You can write your own custom providers, of course, and we have providers for a lot of other things than just the ones I've shown today. But I think the flexibility of that is positive in terms of, areas we may want to grow into as a community in the future. But I've talked for like 30 minutes now, and y'all are probably all really tired of that. So I'm going to take some time now to see if anyone has questions or anything else you'd like to see. And also, I apologize. I just saw the message for zooming in a bit. I will make sure to do that from this point forward.
I guess I had if I think of our typical workflow, it's about trying to catch errors or typos or whatever as early as possible when somebody's opening up a PR. What sort of validation can we do with Crossplane at pre-submit time?
Yeah. So right now we don't have great support for validating against like if the cloud provider is going to reject it, right? Um, just because that's kind of a difficult thing to do. You could create a resource, and this is something that we're looking at supporting in an upcoming release that is observe only, which allows you to do some kind of like dry run type of stuff and see if it's even valid and would be rejected. Another aspect as well is since we're running in Kubernetes, in terms of actually just fitting the schema defined by the resources, you can run against validating webhooks. And you can actually execute those, in a pre-submit outside of the actual cluster. So you could run a validating webhook against a configuration without actually then, passing it along to be created on the cloud provider.
You had you had a passing mention of currently using um, HashiCorp's tool underneath, and I wasn't sure if that was alongside or if some of the implementations use that, or if you could speak more clearly.
Well, just to verify what you're saying, I did mention that we currently use Terraform in working group k8s-infra. I didn't make any mention about Crossplane using Terraform.
Oh,
However,
thanks.
that is an interesting thing that you bring up though, because there are a few different ways that you can actually use Terraform or HCL as you like alongside Crossplane. We have a number of videos I can point to on that, but one would be using the HashiCorp k8s operator to be able to create things via HCL, which would basically just render out Kubernetes objects from HCL. The other would be actually having an operator that just runs Terraform apply underneath it, which basically gives you a wrapper around just any Terraform configuration you have. However, at that point, you're kind of losing out on some of the benefit that Kubernetes provides in terms of the spec and status and that sort of thing.
I want to point out something I think is you've done a good job on. Is I used to work a lot with Fog and with Chef Client, and there I had the hardware or the cloud provisioner that they used on top of that, and it was difficult when you tried to uh, normalize across all the cloud providers, and having this abstraction happening at a user configurable level is I like their approach. It looks great. Very hard to do on a programmatic level in code, and then have
Yes.
people come in and request, may I change that for my environment?
Right. And another thing that if you're familiar with like config connector or ACK or any of those, that's typically what folks compare Crossplane to, which obviously those are provider specific, and there are merits to that approach as well, of course. One of the differences is that all of our managed resources here, so all the things when I run like kgit GCP, these are all cluster scoped resources. And there is some logic behind that. Part of it being that we talked a little bit about how you can expose things at the namespace or cluster scope. The actual granular resources we always view as kind of like an infrastructure admin kind of thing, and so that's why they all exist at the cluster scope. And if you think about the Kubernetes model of having nodes at the cluster scope, and those being consumed by workloads in namespaces, by being scheduled to them, of course. It's a similar model to that. But it is something that folks a lot of times will be like, why can't I create my Cloud SQL instance in, namespace foo? And so that's kind of the logic behind that. You could always create an XRD to expose that at the namespace scope if you'd like.
Yeah, this looks very flexible and very interesting. I apologize for showing up late. I guess I could have some more questions about just the the general workflow, but I guess to have a concrete example to work against, one one pattern it seems like is pretty clear and has a lot of changes to the K8s repo is stuff related to the staging repos. And I would be interested in maybe considering a pilot where we figure out how we could create like a higher level abstraction for staging repo. So that would make, ensure like we're setting up the correct projects, we are setting up the correct service accounts, we're enabling the proper services. And then I think there's some attachment to like create some service account resources and get them deployed in another cluster and use workload identity to sort of bind those, which I don't think you need to explicitly support as a first-party offering. I think it's more like adding an IAM binding to a service account. Does that sound feasible to you?
Yeah, there's definitely a lot of kind of like plumbing that we see people trying to do. And I've shown kind of one way to do that. A good example of that was kind of the putting like the Helm chart into the cluster and kind of how you can view providers as basically the API being provided by something else that gets created by another provider. So you can do some of that plumbing that you were are referencing there with like service accounts and IAM roles, which some of those are already supported in provider GCP with cross-resource references. And we can talk about that a little bit more if you'd like. There's also the ability to, extend that, right? So if you wanted a specific provider for doing that operation, you can always basically drop down and write the code and have a specific provider to do that. But we'd like to be able to support all of that kind of at the composition layer and be able to connect those things together with it.
Yeah, I hear you there. I guess the reason I was thinking of that is like the staging stuff is pretty well constrained to the permissions that you and other folks in the release engineering subproject already have. Mm-hmm. And I don't think it requires too much in the way of touching like the entire GCP org or stuff like that. So I feel like if we have any paranoia over automation accidentally blowing away things, this kind of constrains us a little bit to sort of a well-scoped area with a well-understood pattern. I feel like at the moment, like I'd love to say another good use of this could be like to create a composition to describe a Prow service cluster and to describe a Prow build cluster. We could use those to stand up Prow build clusters in different cloud providers using whatever credentials are available to us from the CNCF. But I feel like there's probably more plumbing involved there at the moment. So if I wanted to demonstrate a quicker, easier win, I'd probably look at kind of taking away the toil and the typos and stuff from staging repos. I guess, so to go back to my workflow questions, so at pre-submit time, I guess what I heard you say is we could do like validation of the spec that gets generated, like, yeah, it's a valid CRD, but we won't know whether like it attempts to link things together that don't exist, for example. That's something we would only find out at runtime. So what like what mechanism is available, or how would you suggest we could set things up so that like contributors who don't necessarily have access to the management cluster are able to see how and why their pull request failed to deploy?
Yeah, so I think at some level we likely want to give people, read access in some form or fashion, whether it's via separate dashboard or actually via the GCP console or something like that, to see the objects, because a big benefit of we get from doing it this way is that you can actually look at the Kubernetes objects and say, oh, I see, that this one is unhealthy, and it'll tell you, like, you referenced this network to provision the cluster in, and that network doesn't exist. So being able to expose those back could be something that there's some automation with the CI/CD pipeline that reflects that back, with a comment on the pull request or something like that. That's not something that Crossplane is going to do for you, right? It's just you'd want to be able to see the cluster. One of the things I can go into a little bit more, and I mentioned this a little bit kind of early on in the discussion, is Upbound, the company that I work for, and is behind Crossplane, provides kind of a hosted Crossplane service. So if we look at something, like this example where we spun up other clusters, taking this control cluster and putting that in something like Upbound Cloud, where it's, that's hosted elsewhere, you can do things like, and I can walk through this further if folks would like, but you can do things like provide dashboards to folks to have, let's say, a workspace that was, let's say it's like RelIng or something like that. And then once you installed those different namespace scoped and cluster scoped things, you could make those visible in the namespace. So folks could click on that and it would say, oh, the status of this is healthy or not. This is referenceable or not. You can give them, read only. It's based on Kubernetes RBAC, of course. So you give someone read access, etc. So that would also be an option as well. But in terms of actually reflecting that back on the PR, we would likely need to look into some other process to, propagate that back in the form of a comment.
Yeah, I hear you. We're lacking right now on post-submit jobs being able to report back to PRs effectively as well. But I guess like closest thing I'm reaching for would be like maybe people are knowledgeable enough to go look at test grid for the job that ran for like getting an image built and pushed, and so they can see that that failed, and then they can click on that and then they can see why. So it could be we could have something like dump those resources or whatever. I'm just trying to sort of pretend like I'm Tim for a little bit here and get really paranoid about public access to a cluster that has privileges to manage all of our infrastructure. But okay, let me see. What was the other thought I had?
One of the things, sorry, go ahead.
No, please. I was going to say I'm talking a lot now too, so I'm curious what other folks
have. One of the things that I'd like to talk just a bit about to kind of like assuage some of those concerns about deleting infrastructure is obviously in this Crossplane model, you have a representation of the cluster in the form of a Kubernetes object that represents the external infrastructure, and then you have the external infrastructure itself, and those are from the view of a provider, right? Those are two different APIs, so it's kind of like brokering the two different states here. And so all of the managed resources, which I was mentioning earlier, are kind of like, the XRM model, if you will, have a common set of fields. One of those being a deletion policy. And you can see here that the two options you can have are delete or orphan. So one thing I would definitely recommend as we started out with this in the Kubernetes test infrastructure space is using orphan for all of these, which means that no matter what happens in the cluster, it's never going to call delete on that resource externally. So, the worst case scenario is you lose access to manage that from the Kubernetes cluster, the Crossplane cluster. But it's not actually going to, take down the infrastructure with it. there's also some things we can get into about assuming control of existing things, you know, which in this case you might want to do, right? If you orphan a resource, you're like, oh, I want that back. Crossplane also has facilities to be able to say, this resource already exists, please essentially import it, and start reconciling it from that point forward.
To go further on that question, yes. So we have a bunch of infrastructure that exists already. Is there any way we can sort of easily import that into sort of lower level cross-plane resources that represent sort of like the raw infrastructure, so that Crossplane's like aware of it, and then as we maybe created higher level compositions and started to claim ownership of those things, like is that feasible?
Yeah, so there's two different parts you're getting at here. One of them is our external name feature, which is where you reference the name. You create an object with an external name annotation on it, which basically says this resource already exists. I know it exists. Please find it and assume control of it and start reconciling it and taking ownership of it. That's, you know, a nice thing. But I think what you were getting to there was likely import it, but don't start managing it yet, right? But like reflect its status here. And that we refer to as read-only resources. And that is not something that is currently supported in Crossplane. However, it is something that is very high priority. And you can imagine that that could be a pretty simple switch. Not getting too into the weeds here, all of our providers, if folks are familiar with controller runtime, are built on what we call Crossplane runtime, which is basically takes controller runtime, put some of these opinions about like a deletion policy in there and enforces those. So you basically, it says, how do I create, update, and delete this resource? And then all of the actual life cycle of it, in terms of like making sure you don't actually delete it, if the deletion policy is orphan, is encompassed in a single library. So being able to do read-only resources would be fairly straightforward in that you wouldn't even necessarily have to have code changes to providers. You could just say update to the latest version of Crossplane runtime, and it will do things like late initialize, which is where we populate spec fields based on an external status, but not ever call the update method, for instance. So that is definitely something that is on the roadmap for us, but not currently supported.
Okay. Yeah, that that sounds feasible. I mean, that question's coming from the fact that like Hippie's working on like an audit script right now, right? And so I'm just thinking, if we move to something other than Bash, like how could we have some process that sort of audits the state of the world, and could it dump it in an output format that's more easily reconcilable? It sounds like possibly we could, it sounds like Crossplane doesn't do discovery, so we'd have to have some tool that did discovery and then could point Crossplane at those resources to get sort of, I don't know, dry run CRDs, basically.
Right. Yeah, that's definitely true. I would say Crossplane doesn't support it yet with my maintainer hat on, but I totally understand that use case. One of the things I will say is a great benefit of being, you know, Kubernetes native is that there's lots of other projects that we can integrate really well with when we represent things as Kubernetes objects. So this isn't directly what you're talking about, but the vast majority of folks who use Crossplane also use something like Gatekeeper from Open Policy Agent, which allows you to, you know, add policy. There's other projects that do auditing and that sort of thing as well. And Crossplane will be fully compliant with that because it is just Kubernetes objects in the end. So there could be some nice wins we get there from just, you know, standardizing towards the Kubernetes API with all of the different tooling.
I think some of the things that would be interesting here on that, and I know it's asking about importing existing resources in Crossplane or composition. When we have that reference to the represented backend, having the state or the status pulled in full of what's available to Crossplane because I think there's the surface area exposed by Crossplane, and then when we do have a reference to those the object underneath, being able to audit what's there from the provider perspective or the underlying data assets. And I think that's kind of the question with regards to auditing is what is currently there and how far would we have to go to be able to see when changes occur, to review those, during our meetings.
So are you saying like, as an example, I guess, if a cluster scaled up its node pool or something like that, getting that kind of information and reviewing it, or potentially making changes to IAM or something like that, are those the kind of changes you're thinking of auditing here?
Possibly. I the reviews, what we've been doing so far is doing the command lines for the representing and dumping the YAML, so that the state, so it's not necessarily that one attribute, but the underlying configuration object by the provider, in this case GCP, so that we can, it's been to track, currently been to track when manual changes occur, and so we can go, why did that happen? But for the managed objects, being able to check things that may not be exposed in the Crossplane configuration extraction.
I see. So everything that the cloud provider exposes in the API, right, for let's say like RDS in this case or something like that, will be reflected on the managed resource for Crossplane. If we look at the abstraction level, and I can talk a little bit more about why we do that. We are huge sticklers about representing every field that the cloud provider does at the managed resource level, which sometimes can be very frustrating because some cloud provider APIs are not super intuitive in managing things as Kubernetes objects, but we do express all fields there, which makes sure that, every change, for example, like the status of, if we looked at a GK cluster, is going to have lots and lots of fields in that provider here. And you can see even RDS here has a lot of them. So you can see all of those at the managed resource level. And then, from the abstraction, you can see how that maps down to those, and you can imagine how you could aggregate kind of like the net things behind an abstraction and all the changes that were related to whatever you define. So if you have a prowl cluster abstraction, you could say these are all the resources that are a result of that abstraction, and these are all the changes that happened to those resources in the last 7 days or something like that.
It's been a while since I've used AWS, so I don't know if you've had to solve this for other providers. I know that Google Cloud often has alpha, beta, and GA versions of the resources that it offers. Does Crossplane allow us to, so like I know we have to solve this with Terraform, for example, by using a provider GCP and a provider GCP beta to get access to certain features. Does Crossplane allow us to do something similar?
So we have, the benefit of Kubernetes API versioning, which is nice in that we can have, a V1 beta 1 RDS instance and potentially a V1 alpha 1 as well, and potentially some conversion webhooks between those. However, sometimes those APIs and those changes on the cloud provider side don't fit into that model really well. And in cases where that happens, we've done things like having just a different GVK for that resource. We typically try to keep everything combined into a single provider, so you can get all of that access with a single point, so you don't have for instance, a GCP beta and a GCP alpha or whatever. So you would likely see something in an extreme case of like calling it beta RDS instance or something like that, if someone really needed access to a specific kind and we already supported a different version of that. So there's a number of workarounds we can do there. But it's mostly based on user demand.
I guess one other like paranoia question. So I heard you say earlier that all of the infrastructure level CRDs are cluster scoped. So my paranoia would be, we're using these great abstractions that are namespaced elsewhere. So we're ensuring that like only RelEng has access to the RelEng projects. And let's say we have somebody hacking on Slack infra and some of the other apps that are deployed in the AAA cluster, and they're hacking on using like the Helm provider for that. But they accidentally do something that could allow them to delete permissions or whatever, or delete infrastructure level resources that correspond to RelEng abstractions. Does Crossplane protect us against that?
So I would say it depends. It depends on how you structure your abstractions and protections you have in place of like OPA and that sort of thing. One of the things that we see folks do is, for instance, when we're looking at these GCP types, you'll see things like, you know, UIDs appended to it. We'll see folks have different naming strategies which guard against like someone creating a, you know, two different namespace clusters, creating a GK cluster that have like conflicting names, or deleting something or something like that. And so there are various ways to get around that. Once again, OPA is a good example of that, saying that, you know, this person can only create resources with this naming pattern or label or something like that. And then in terms of, you know, potentially like the RelEng team in that scenario being aware of that, we try to, and you can also control this, reflect the status of the thing that's causing the abstraction to be, you know, unhealthy in the abstraction. So the RelEng team wouldn't necessarily even have to know specifically, you know, the cluster scoped resources status. It would be reflected to them in the status of their abstract type that they created, and say something like, you know, your service count or whatever is unhealthy, and that's why this whole abstraction is unhealthy. But certainly something to keep an eye on, right, and define a strategy around, because Crossplane isn't going to enforce that you can't do those sorts of things. So it is something you need to be thoughtful about when using it, for sure.
Yeah, that totally makes sense. I've asked all the questions, and I know we're at time. Does anybody have any other questions or comments?
One thing I will say is, I know I see many of you in Kubernetes Slack, and you're very welcome to direct message me about any of this stuff or anything else related to anything. So I'm more than happy to answer questions afterwards, and also, you know, give further demos or do POC kind of stuff around this. I think, Aaron, that was a really good suggestion, that we should identify an area with a low blast radius, to test this out. You know, first from a POC perspective, and then potentially from an actually managing a very low blast radius area. And that would be a good pattern to move forward here. And I'm happy to, you know, do that myself / enable other folks to work on that effort as well.
Yeah, that sounds cool to me. My level of interest is high, but it doesn't necessarily match the amount of bandwidth I have to move on it rapidly. So I'd totally be cool helping talk about a POC or helping scope it or whatever. But yeah, this seems pretty interesting. And yeah, I think there are probably some bits and pieces that are missing, and I think you've described like sort of the path forward to adding those. I think it's kind of a matter of like articulating what the roadmap would be for accomplishing a POC, which, you know, can't move on today, but I'm happy to like try to kick that along so that we maintain this interest.
I wouldn't mind helping to facilitate some of this as well. We have some time for it as well.
Yeah, this is the only other thing that's coming to mind right now would be like using Terraform directly. And I know that it's like Terra Grunt or Terraform test or something that could let us do some policy level stuff at pre-submit time using Terraform plan. But I think going K8s native would be a lot more interesting. So I think taking a look at Gatekeeper or OPA would probably also be a good idea, regardless of whether or not we use Crossplane.
Absolutely. I think that's a good point. And another thing I'd mention, not that this effort should involve taking a lot of folks that contribute to Kubernetes and making them contributing to Crossplane. However, it is always a benefit of something being a CNCF project of that. The company I work for, the company you work for, does not control this, right? And so if there is functionality that you need or changes that we need as a group, those are things that can be made and can be driven, by input from this group.
Totally. Yeah, I hear you loud and clear there.
It might be good on the initial POC to get a list of the primitives that we need to do this scoped blast radius and see what pieces are missing, so that we can see how long of a lever we need to pull to try to pop the lid off of it. Eh?
Yeah, for sure. That's one of the things that I think I can take as an action item here is look at the current things we manage with Terraform and diff that with the list that we are looking at there on the CRD's website and just kind of circulate that. One thing I will say is we do live streams of like adding these new resources. So if folks are interested in being part of that effort, once again, that's not the goal here to have a lot of people go and work on Crossplane now. But if that is something of interest, more than happy to support in that / do that. So
yeah.
Yeah.
That would be cool. My only comment on the existing use of Terraform is right now Terraform's pretty much used just to stand up the AAA cluster and just to stand up the Prow clusters. So it could be interesting to look at it, but if I were driving for a POC around the staging repos and stuff, that's still all Bash. So
right. Good point.
Thank you so much for your time. I really appreciate you volunteering to put this together and then schedule it and then remind everybody that it's happening and then showing up at the meeting even when this wasn't scheduled. So this has been very cool, Dan. Thank you a ton.
Yeah, absolutely. And thank you all for entertaining it. And yeah, excited to see if we can improve some of our processes here.
Cool.
Very exciting. Amazing.
Thanks a bunch, all.
See you, folks.
Thanks, Daniel. Cheers.